This is lesson 5 in SQL. This week we're going to be looking at a couple more built-in functions that we didn't talk about last week, as well as some advanced things that we can do with the where clause to add some more filtering to our searches. So I'm just going to SSH into the box here. And I'm going to, again, connect to this CITPT 413. Before I do that, let me clear my screen. Just going to be using this one for this week's stuff again. Don't need to be creating anything or anything like that. We're just going to be running some functions here. So we've got a couple tables in here already. We're going to be looking at this notes table for these functions. And so if we look at this notes table, we've got a bunch of stuff. You know, every note on this site has an ID, a title, a description, a file, course, school, so on and so forth. And they have this cost. So all these functions that we're going to be looking at have to do with numbers. And so it tells you this is a number, this is a double with precision is the type, and it has a modifier and that it can't be null. So the functions that we're going to be looking at are sum, average, minimum, maximum, and then one more we're going to throw on there, which is distinct, which works a lot. All these functions kind of work like the count function that we saw last week that are built in. So if I just come on here and I say, give me the cost from notes, I get this big list, and you see it's just a bunch of numbers, basically, more or less. So what we can do with that is we can say, give me the sum of all of those rows combined. And it returns and says, okay, that's 688.5. So maybe you want to total something in your within your database, you know, to see, I don't know, how much stock you've got on items, something like that, you know. This is a real quick way to go ahead and run that. Another thing we can do here is we can say, what's the average cost that notes are selling at on this site? Okay, so our average price is 21.51, you know. So what is the minimum that someone would pay for a note on this thing? Well, the lowest one is 3. What is the max? 123. So we can do all these, you know, built-in functions, and they work, and they're very fast, as you see. You know, you can run that over a data set of, you know, a million rows, and it's still going to be very, very fast, as opposed to you writing your own. So if I go back up here and kind of run this first one, you'll see there's a bunch of duplicates in there. There's 32 rows of data, but there's a lot of 5s, 10s. I don't know if there's anything else that duplicates. 123, I guess. Duplicates of 12 too. So maybe you just want to see, with this distinct, we can just say, give me only the results that are unique. Okay, well, there's only 8 actual unique values in there, so these are the 8. Everything else is a duplicate of one of those 8. This comes in really handy a lot of times when we start to get into more advanced stuff, when we start to get into joins and things like that, and your joins start to duplicate rows. You'll want to separate out to get only the distinct data back. You don't want duplicate rows showing up. For this, it works in that, you know, hey, I just want to see what are these things, and so on and so forth. So those are the functions that I wanted to cover. Let me get out of here and clear this screen and come back up to the top. So we have the where clause we started to get into last week. We were, you know, able to see something like select from users. We'll just say select ID from users where ID is greater than 10. We got a bunch of IDs back, you know, something like that. Another thing you can do is maybe you know specifically, we saw last week, select ID from users where ID equals 1, right? We can select a very specific user. Well, if you wanted to select multiple we have this in keyword, and you just give it a list of things. So one, I don't know what any of the other ones are. We'll just try some numbers here, see if we get anything. Okay, so I said, give me the ID from the users where the ID exists within this list of stuff that I'm going to pass. Okay, so they all existed. So there's 7 things that I got back. We could also say where they're not in that list of those 7 IDs that I gave, and then it's going to give me everything else. So this in keyword and the not in keyword allow you to have a little more control over the results that you get back if you're looking to target very specific things that you already know beforehand. Another one, so if we go here on this users table, so in the users table they have this column called PayPal, which would be their PayPal email account, and it doesn't have a not null constraint on it. So some of the values in PayPal might be null. They might not exist at all. Well, if you wanted to select where PayPal equals null, if you wanted to do this, this actually won't work. It's going to tell you there's 0 rows. The way that you say if something is null or not, it can't actually be equal to null within a database. Null is not a value. It is a lack of a value. So within some programming languages, you can write equal null, and it works out and it's fine. Within databases, they themselves don't. There's no value stored. There is no null. There's nothing. So if we look here, we just simply say, let's see here, greater than 60. I don't know. It should only give me a couple rows back. So it gave me a couple rows here. It gave me 9 rows, and you'll see that this is null, this is null, this is null, this is null, this is null. This one's not null, and this one is null. So if I only want to get them where PayPal is null, we have to say is null. Pretty simple English there. Just we can't use the equal symbol. It doesn't work. So you'll see, hey, here's all the ones where PayPal's null. There's 37 of them. Conversely, if we want all the ones where it's not null, you say is not null. Okay, here's all the ones that are not null. These ones must be spaces or something like that because they look very null to me, but apparently they're not. So let me go back up to the top here. So that's how you would select something, is not null or is null based on that. So previously I ran, this little command here where ID is greater than 60. It gave me 9 rows back. What if I wanted where ID is greater than 60 and PayPal is not null? We can just throw that on there with an AND statement. So this is going to say, hey, select from PayPal, select PayPal from users where the ID is greater than 60, and this condition also must be met. PayPal is not null. So we know that there were 9 rows previously. 2 of them had values. Maybe, let's say, maybe 3 of them did. Maybe 1 of them had a space. Okay. So in fact, 3 of them did. 1 of them has a space. These other 2 come back with actual values. We could, take it a step further, and PayPal not equal to space. I don't know what it's equal to. Maybe it's equal to empty text, but for whatever reason that's not null. So maybe the web interface saved it, and it saved it as an empty string as opposed to null. So when I said select PayPal from users where ID is greater than 60 and PayPal is not null and PayPal is not equal to nothing, then we get these 2 rows. So we're seeing that you can get things that aren't null. You can also combine with this and to say extra things. We could also use an OR statement. So there's ands, there's ors, there's nots. So select PayPal from users where the ID is greater than 60, or let's say PayPal is not null. So we got, you know, some more values there. We could even go a bit further, make this a little more complex, where ID is greater than 60, or let's go ahead and throw some parentheses on this thing. Once you throw parentheses on, you start getting control of order a bit more. Okay, so now we've got this thing. It says select PayPal from users where the ID is greater than 60. So we know that that's 9 rows from previous. Or PayPal is not null and PayPal is not empty. So we get 21 rows. We can assume that some of these are greater than 60. We can actually just see, throw that on there. Let's see here. We want the ID row and PayPal. So we know that some of these came because their ID is greater than 60. In fact, a lot of them. We could take it a step further and say order by ID. So now we get a better view of what we're looking at. So we know that these ones all came because they are in fact greater than 60. That's the 9 that we knew about. Whereas these extra ones came because, as our statement said, the PayPal is not null and it's not empty. So that was our result set. So if we were to just say, without these parentheses, then we have where ID is greater than 60, or PayPal is not null, and PayPal is not equal to nothing. This now applies to even those that are greater than 60. So if we look at that, it's going to be a different result set. It's not going to be a different result set. So you can add parentheses to have a little more control. I don't know that it is actually a different result set. How many do we have here? 21 and 21. So it's telling me that these are all null. So anyway, you can use ands, ors, parentheses to have, you know, some more handling on that. So the last thing that we're going to look at is searching. So on this users table, there's an alias field, and for the most part, the aliases are names. You know, they're quite simple things. And maybe you want to search, like, you know, these are usernames on this database, right? So maybe you want to search the usernames on the site. Well, how do you do something like that? You can, you know, do where the alias is equal to, so I know my username is Lakesta. So if I say that, okay, it gives me back Lakesta. But what if I don't know that it's Lakesta? What if I know that my name is Lake, right? Something like that. Well, there's nothing returned. So what you all need to do is to say, well, I want something like Lake, but not Lake. It's close to it, but it might not be exact. So there's a like command. If I do this, it's not going to give me anything. The way the like command works is that there are within Postgres, there are 2 wildcard matches that we can use. So one is the percentage sign. And the percentage sign just says match any characters either side of this thing as long as somewhere in the value there is the word lake. So if I search that, okay, it found lake stuff. So if I were to take it off the front, it would still work, because lake now is the first 4 characters. It says match anything that comes after that, just accept it. If I were to switch that and say, okay, anything and then lake, it doesn't find it. It's saying there's nothing that has anything before lake with nothing after. That's the key. Because as we saw up here when I said anything before and anything after, well, it found it, right? But I said give me anything that ends in lake, essentially, is what this statement says. So we can look at another one here. If we do this, should get... Yeah, so we've got 2 users in here. We've got Jonathan1 and Jonathan2. So if I say give me anything that's like Jonathan, well, it gave me both of them. So this is, wildcards. Again, for this one, we could use the underscore, because it is literally just one character. If we did that for lake, it wouldn't work, because there's actually, you would have to use 3 of them. So it's just a little more difficult, because it's going to match very specifically. If we only use 2, right, it's not going to find it, because there's 3 characters preceding. So that works. If I were to do this, say they type this in. Okay, it didn't work because I typed it in capital, right? So there's another command, it's called ilike, and it just means that ignore the case. That's what the I stands for, ignore. So just ignore whatever the case is and continue to search as you would. So that's they have that in most databases. In MySQL and MS SQL, they have the like and the ilike commands, and with that they have the percentage sign is always the wildcard. There are some other things that other databases do, more wildcard matching and things like that within Postgres. So here we're looking at pattern matching. I'll throw this link on the notes. We've got this like, and as it says, an underscore matches any single character, a percentage sign matches any sequence of 0 or more characters, and then there's also a not like if you wanted to not match. And this is a really simple use case, the like. It gets used very, very often when you're searching for things. But Postgres also has quite a bit more that can be done with it in terms of regular expressions. If you want to use the similar to, you can get full-on like POSIX regular expression searching. So if you're looking for, maybe you're searching an email address in usernames, right? You want everything that looks like an email address that are aliases. You could search, an entire email which is always something crazy, like you want some string at I don't care how long, and then you want an at, and there can only be one of them, and then another string, and it has to be at least 3 characters long, and then a period, so on and so forth. And then there's a domain, and that's a string, and that has to be at least 2 characters long. So you can, make it search much more in depth than I'm doing with just, hey, these letters at whatever. But if you're writing a simple search for like maybe you're making like a blog website or something, right? And you want to be able to search through post titles. So you can write a search that says select title from posts where title I like, and maybe you're searching for something on SQL, where it's like SQL, and you throw 2 parentheses around it. That's a very, very simple search. It makes it runs through the database quick. It makes your site much more user friendly. But just know that there are you can get much more in depth with these types of things And here, it'll give you the POSIX if you want to go all the way down to that level. If you're used to regular expressions and other languages, it's a lot the same. So there's a bunch of examples on here. There's details. There's all these things about the greediness and the non-greediness of what you're writing, the escapes, the built-ins. So I actually wrote it incorrectly. I was using /s for alpha and m when it should be /w. So so there's a bunch of stuff on here if you care to get that deep into it. Whereas I personally, for most of the stuff I do, I just use the like command, or rather I like command, so that I can get the ignoring on the case. So there's one other thing. I'm not going to show an example of it here, but it's kind of cool to see, just to kind of know about. I've used it in the past. It can be really kind of a strong thing, but it's kind of weird. So I'll give you the example. So this thing is called a fuzzy string match, and it basically tries to find similarities or differences in strings. So SoundX is a way that you can test to see if something sounds like something else. So like rhyming words or something like that. If the quick brown fox, and then I have another sentence that says the quick brown fox has. Well, how do you search to see likeness between the two? Well, you can use this SoundX thing, and it'll basically tell you whether or not the two things sound alike. So here's some examples on this site. Here's checking Anne and Anne. Do they sound alike? Anne and Andrew. Anne and Margaret. And it's really was intendedly, as it says here, used for names in the U.S. Census back in the early 1800s. And it's not very useful for non-English names. It's not very useful for things with spaces in it either. Kind of gets quite confused. There's the Levenstein method of doing things as well, and it kind of uses this a little bit. So there's some other ways to do this to kind of sound check things to see if they sound the same. So one of the reasons that you might use something like this, and I'll tell you where I used it in the past, is I had a client and they had a database and it had a bunch of recipes that they had entered in. And a lot of the recipes were entered in by different people that didn't know each other, and they were all stored in there, and they had kind of become duplicates. There had been, 100 recipes for chocolate chip cookies, let's say. And they were all kind of written out like that, like chocolate chip cookies, but then they'd have like a different word in them, something a little different than just chocolate chip cookies. Be like chocolate chip cookies large, chocolate chip cookies tiny, right? But they were using the same recipe. They were basically the same data otherwise. So they wanted a list of, hey, what are all the things that are actual duplicates within this database? We can go and check them out and kind of remove them so that our site doesn't have a bunch of duplicated data. So we were able to use, we actually used a Levenstein function to go in and check and basically run across the database to say, hey, give me all the things that sound like something else in the database where there's at least 3 of them. There's at least 3 copies of them across this database. And then return all that data back to us so we can go and individually check them out to see if they are, in fact, just duplicate data or if they really are, a different recipe for chocolate chip cookies. So that's kind of, an example where you might use something like this as opposed to using like the like command or the and or anything else within the where kind of range there. So I'm not gonna give you anything that uses the SoundX. I just wanted you to make a mental note that it does exist. Maybe you have a use case that you've been waiting to learn about this thing or something for, but just to know, for future reference, it does exist. You can check things that sound alike, even if they're not exact matches, even if you don't know what they are, right? When you're searching for chocolate chip cookies on this database, the query that we ran it just said, hey, give us everything that sounds alike. We didn't say everything that sounds like chocolate chip cookies. We should just give us all the results that sound alike at all, and then order them, by their likeness. So, maybe it gave us 10 matches on chocolate chip cookies, then it also gave us 5 matches on apple pies, something like that. It gave us everything in the database that looked like a duplicate of something else. So just to make that aware to all of you. So everything else that we've talked about, though, should use, you'll see on the assignments. So hope that helps. All right, thanks.